Okay, good morning. Let's do another video. This time we're going to be covering communication. So this is for the weather balloon project. First thing I need to do though is I've been using a breadboard and I run out of these guys, or the double male versions of them, so I'm going to have to do that. So bear with me for a moment. Let me just remove this laptop. Not drop it again. There we go. That'll probably fall over in a minute. Let's start butchering some of these up. Probably need, I'll say 4 or 5. Let's go with 3 just to mess things up. So 3 and 3. Beautiful. Normally I just order some more, but for some reason, the ones you use the most of, they never give you more than you need. They always give you equal amounts of the male, the female, and the male. And that's a bit of a problem because, like most, you use the male. That's not ideal because you run out of them instantaneously. It's always when you want to do the last component anyway. So let's butcher some of these up and hopefully that'll go well. Normally my luck when I chop the wrong ends off or drop the battery cap and still haven't found it. It's just gone to the shed gods. Let's just strip these. I need some better wire strippers. Hope everyone's day is going well. It is very warm in here. A juicy 25. What I do for AC. Alright, it's a shed, so what do you expect? Okay, terribly stripped. Let's twist those up and tin them. Yeah, these aren't the best quality wires. If you're ever doing breadboarding little projects, I'll show you one of those in a sec. Look how thin these are. You can get interesting voltage drops that you find you don't have when you go to a full PCB. What you can make, I have 2 ways of making PCBs. One is a chemical etching tank and then using photosensitive film that's been manufactured onto copper clad boards. Or the other way I've been playing with more recently is using a CNC router. Hopefully I'm saying that the right way. I seem to have got it in my head to say it the American or the English way. I don't know. It's fine. Sorry about that. It's very unprofessional. Let's just tin these up. Now, you probably get a clamp for this, but I'm not too bothered about the bench, so. Now I do, just because I only have 1 pair of hands, I'll get some heat shrink, coloured way fancy, red, beautiful. So I need 4 and I'll be like, it's always the way. But no, the aim of this episode is to look at what I intend to use to solve the age-old question of getting a signal back from a very high or from a very far distance, such as, cut too many, that's a good start, such as like 40 miles away, and not only that, very high away from most things that you could use next. You could use cellular. But in this case, I cannot. Let me just concentrate on not burning my fingers. I need to get that off there. Very daintily. It's going to make my joints very messy otherwise. I'm doing this quickly, so bear that in mind. Normally what happens is the heat shrink falls off. And I don't notice it until I solder the wires together. Beautiful. Now, I'm sure other people could do a better job of that, but I'm doing it quickly, so Right. Now hopefully my audio is a bit louder today. For some reason my recording's always really quiet. Let's get the good old, oh dear, oh god, Chinese fire torch. We can use a lighter, but I'd recommend using a hot air gun that's setable, because you can set fire to the wires. Well, it is quite fun, but not much fun if you want to use the wire afterwards, or have it at least insulated. Right, let's get you off out of the way. Hello, pen. Solder, I can go over there. Now, keeping a workbench tidy. It's always fun. Okay, camera's still good, beautiful. Okay, so what I'm going to use is satellites, and in particular, I'm going to use this Iridium satellite transceiver. Very cool module. I'm not showing you that's under my finger because it's the registration code. And I'm also showing the serial number, but hey, I will have to sort that out and hope no one screws with my device. But what it is it's got it's patch style antenna. Probably seen these before. These are normally used on GPS receivers, but in this case they're actually, you can use them in both directions. So this is, I can't remember what the megahertz range this type of antenna works for, but then you've got on the other side, screw it, I'll show you anyway. Supercapacitors, like with most modems, they require bursts of data, and for that it require a lot of power, so they need kind of a stable-ish power supply. You've got this 1mm set of, what's it called? 1mm spaced connector. I'll show you the pins on that in a sec. And then you've actually got the Iridium part. So this is the Iridium modem, or transceiver as it's called, transmit and receive. And then you've got this rock block, if I'm saying that right, breakout board on the bottom of it. So what you can actually do, if you can unscrew that and disconnect it, because you notice it has an external antenna, and you can actually set it that you can use that antenna port and have an external mounted antenna, or you can use the integrated one. There's a little plug in there, an SMA plug. I usually swap it, but you can unplug that and replace it. They're not cheap. So I hope it comes back to me. But anyway, I'll pop that aside. Now, why am I using satellites? Well, it's very cool. That's the other one thing. Hopefully you can see this and you haven't got a massive reflection. The other thing is the coverage. So Iridium have 66 satellites in its constellation, and they give you, except for the poles, global coverage. What's quite ideal because it's one less concern to worry about other than losing it. Now, that module, where is it? It's here. Obviously, nice little drawn picture, and we'll get our Artist of the Year award for that for certain. Its typical usage of power is also quite interesting. So it sits about 100 milliamps. It does have a sleep pin. I'll go into that in a sec. But it's bursting at 450 milliamps, so quite low power consumption considering it's firing a signal up. I think it's 740 kilometers. So obviously this is to scale. I wouldn't give it a very high accuracy, but Earth is there, and these are actually the distance the satellites are spaced out. I think they're more or less spaced out like that basically, so they don't cover the poles, and then they cross over. I think they're 100-minute orbits. Doesn't sound quite right saying that at that distance, but hey ho. There could be something lower, but from my understanding, they're quite far out. So this signal is going to go out the atmosphere and come back to us, and we can send messages back down to it. Costing. So this unit is £220. I wouldn't, I'd always say if you're going to use it on a project, don't use it on one you can lose. It's not ideal. And the other cost is actually transmitting data. So they charge it on a monthly rental that you can cancel at any time. It's about £12 plus VAT. So if you don't want to use it for a few months, you can just stop it. The other thing is they do it on data throughput, and they break it up into 50 byte packets, and then they charge it at 50, per the 50 bytes. So if you can send up to about 380 bytes of information in one go. And that would be broken up into 50 byte segments in cost. So the cost range, like you can buy a lot of credits. They use a credit system. If you want to get the lowest amount, like 50 credits, it's 14p per 50 bytes. And then if you want to get a slightly higher amount, 1000, it's 9p. So you can see the price is scaling quite nicely there. Well, nice to see at least. Still not nice. And then if you can go up to 100,000, or you can actually speak to them and get different costings for it. What's good? So that 10 pin 2.5mm output here is actually here, and what that gives you is it uses serial, so it gives you receive, got a clock, no I think I can't remember the name of that CTS, RTS again, can't remember the name of it. I've seen something about ITC on this. Network availability signals, that's probably going to be high or low, just to say when it's connected. I'll probably just use has it got a good enough connection. Ring indicator, that from what I've seen is good if you don't want to receive all the time, or check. So every time you check, you use a credit because it has to send data to get data. You can use a ring indicator. So whenever you want to see if you've got a message, they'll ping the device, and then this signal will change, and then you'll know you have to call a receive or send a receive. You've got the COTX, got the sleep pin. Again, if you want to do low power solutions, dragging this down will sleep it and it will go down to like probably a milliamp or so. 5 volt in, battery voltage in, and ground. So what I'm going to use is battery, because this project's probably going to be running on a 3.7 volt LiPo, and if I have to convert the voltage up to 5 volts and then pull it back in, it's very inefficient. So I might as well just try and directly use the battery wherever I can. Otherwise you're just needing a bigger and bigger battery, will then need a bigger balloon, they need a bigger parachute. All those fun nuggets. And then this is made by, oh, I've dented my board, my whiteboard. This is made by Rockblock, and this is version 3. They do other ones as well, like waterproof models. Just the module itself, if you want to make your own breakout board, be honest with you. I could have done that, considering it's just what's on here. A few components that I didn't see before. Yeah, you could make that yourself. It would probably save you about £70, but your own time is worth money as well. So let me stick this away. Okay, now I've been busy since the last time. A, cleaning this bench, and B, watching the whiteboard about to kill me. Ignore a lot of things on here. Alright, let's see if I can zoom in. I can, and now, how's the audio quality? Good. So, since last time, I spoke about using the Arduino 328P, or the 328. It's a very common Arduino, very versatile, very cheap, very low power. However, in another project where I was playing with boat propulsion, electric, I figured it's quite limited on RAM, 2 kilobytes. I came to a problem with, if you ever want to use screens, they require a buffer to be created for them, and in that case, with this size screen, it eats up over half the buffer, or half the size. So you run out of RAM, and then you start getting weird stuff going on. Like, a big thing about Arduino is memory management. So I'm using a Teensy 4.0. I did actually touch on the 3.2, but I thought, why not? Let's go to one of the later versions. Here it is. And this has 1 meg of RAM. Quite a lot more. Also has a crap ton of like additional outputs. The reason I didn't really want to go with this is I noticed these things pick up a lot of noise. Also, the clock speed on this, the other one is 16 megahertz, and this sits at typical 600 megahertz. You can overclock it to over a gigahertz, but then you start needing cooling. Basically, it's a full ARM chip on here. A bit overkill, so I've clocked it down to 25 megahertz because otherwise it uses a lot of power. So yeah, spin it around. Also, nice thing about this, it uses USB micro instead of just the straight like serial connection, and obviously it continues on the back. But ignore, I'll cover these in other videos. These are just sensors, me playing with a battery, boost back, and then I'm playing with a screen not for the fact that I'll be using one. It's just nice to see data on it. Right, so that connector with the world's smallest wires is here, and whenever you get like connectors like this, I always recommend you either glue it from the connector back, because if you're going to be plugging this in a lot, you're going to need strain relief, and the only strain relief they get is actually on the bit where it's crimped into the metal terminal. So I just add a bit of glue and it really strengthens that up and means it's not going to suddenly break on you. And you're going to be crying because these aren't that cheap either, about 10 to 15 pounds. You can probably find them yourself, but might as well order it from the same guys. And then what I've done here is I've actually labelled them because my luck is I blow things up. And I do not want to be blowing that up. So as I say, I was going to use 5 volts, but I found that with this 3 amp boost buck from this 3.7 to 5 volts, it was actually because of those supercapacitors needing charging, they have a large inrush current, and because of that it then crashes out all of this stuff basically, makes it very unhappy. So I'm going to run it off battery. Hopefully you can see that. So what we've got here is black ground, so what I've done is positive negative for the battery. I've run that ground in, and white is battery. So I've run that also to the side. I haven't got a switch on here yet, to be honest. No, it's fine. So I have power wired in. Now TX and RX. So if we bring back this guy, and this comes with 4 serial interfaces. You can also add software serial on Arduinos where it fakes it, and because it runs so fast it can mimic serial. So we're going to use 15 and 14. So if we look at using that highly sophisticated cable I made, let's break off 2. Oh, that's sensible. There we go. Okay. So let's find TX is orange. Let's plug you in, and we need to go to RX. What is pin 15? Ignore what these wires. Apologies. It's just breadboard. It's nice when you go to a PCB. I can tell you that. And pin 14 is TX3, and that should go to RX on this side. Gotta find it first. I have a feeling it's yellow. Come it. There we are, RX. That's next door neighbour. Beautiful. And then we're going to bring this guy in. Show you all the numbers. Now plugging it in without breaking it. That glue coming in handy. And again, if you want to then have this always plugged in, put a bit of block glue on it. It just stops you from running the risk of it coming undone. Because you don't want that to happen, and you don't often check it. So we've got already has a built-in USB to serial. Oh, these are very handy, by the way. You can get them on Amazon, about tenner. They give you milliamps and how many milliamp hours you've used. It's a safety test, ironically, but I don't use it for that. So it gives 3 to 30 volt range and a 0 to 5 amp range. I assume that's for USB-C. I'm not quite sure. Very interesting. Right. Alright, so I've connected the device up. Now we'll probably switch to the laptop, what I've left recording. Let's move everything out of the way. It is getting hotter in here thanks to the summer. Right, this is where I haven't actually got the laptop recording, that always happens. Right. Okay, so what I've got here is I've just opened up a new project in Arduino, mapped out kind of what I want to try. So you've got to set up the device. So in setup, you actually have to go through defining everything you want to do with that device, make the connection, check the connections are all good. Then I want to do every 2 minutes send off hello world. I think there's a library I'll show you in a sec for that. I'll back it up a bit. There is a conditional check I want to make sure. So with this you can actually query the level of quality the signal has. It's a scale of 0 to 5, 5 being the best, 0 being absolute garbage, and I want to set a threshold of probably 2 or 1 maybe, as I don't fully know. And then when that threshold's been met, then it can look at sending a message every 2 minutes, because there's no point trying to send something, throwing it into the message buffer to go, and then it's not being actually able to do it. You'll just create a backlog in the device. And then There's a message. So every time, I'm curious. I'm not sure how this will work. So I also want it to see if there's a message waiting, then it changes to a send and receive, and then prints out the response like coming back. Now I'm not quite sure how that will work, because normally sending also checks for some degree of messages, but I think this will cost you 2 credits if you do 50 up, 50 byte message going out. Every time it receives, I think it costs you 50 credit, 50 byte credit. So I'm trying to just send the message and not receive, but we'll see how that works. It's not the end of the world, as this is only for a weather balloon project, so if it costs an extra £5, and it, I worry that it's not going to actually receive or something. All right. So, library-wise, we have SparkFun. Also did sell this board, but I brought it straight off Rockblock, and they provide an I2C and a serial libraries and examples. It's very nice. So if we're actually on their site now. If we look at the serial ones, as we've just connected that up, we're going to hijack some of this and grab bits that we want from it. So what I probably suggest we do is we get the basic send up, and then we look at the libraries we need to include. What's this one? No others, good. And stick that up here. It's always good if you don't already have this included, just check it compiles. If it doesn't, you can go to this. Please wait, my laptop's a bit slow. You can go to tools and manage libraries, and then you can look it up basically. Probably look it up by that Iridium SBD, or just grab it off SparkFun's website and then import it using the zip function. So it also needs some defines. I'm using Silver 3 on this. Okay, we don't need diagnostics, but it's going to probably get upset and have a default if you don't set it. Then there's instigation of the serial, or constructing it. Beautiful. What is this? So we also need to define, we want to see what's happening and going on. So whenever you do that with Arduinos, you need to actually set up a serial connection. Don't think I need that, and I do 9600 baud rate. And I could do that. I could just add at the end of the program. Probably a 1 second delay would be enough to make sure the serial's up. It's fine. Also need to, as it's Iridium serial, is communicated between the 2 modules over serial. We need to specify the start basically of that too. And by the looks of it, they've got some diagnostics to work out if the modem is present. You know what? We'll have that. Thank you, SparkFun. Now this will just get stuck, basically. I think. No, it will actually just start serial print. Oh, if you ever have bad formatting issues in the Arduino, you have a nice little tool. It's if you go to tools, again, a bit slow, auto format. Serial that, beautiful. What does this do? If it didn't get success, then cry. Okay, got you. We don't need the firmware version. We don't need the IMA signal quality. Hello, we need you in a bit though. What we'll actually do also is just say, so we'll go serial.print ln, so line, so it'll do a print and then break line. We'll put setup complete in there. And some dots for fun. No, we won't put a continuation dots. Good. And now we want to check for signal strength. So we can call it using these useful functions. Test. Well, if it returns anything other than that. Oh, okay. So we have an error message that you can throw back. Okay. Okay. Now what the hell? Excuse me, I'm just reading. As you are. Does it throw in a variable and then throws it back out? So not defined anywhere. Get signal quality. Okay. So it feeds back errors via the function return, and then it throws back the signal quality into a variable it passes in. Okay, or it creates it on the fly. That's fun. So We could make it hold the program, or we could say, and if it doesn't have a good enough single, then hold it. So you know what? This could go wrong. Let's do the simple approach, and we can test it later on. So we've got signal quality, beautiful. And this might break, so we'll find out. It has to be greater than 0. Then we'll just set a message. Well, we could actually run a continue, but anyway, we'll do that. And I've put question mark ring there for a reason. I don't know if I want to be using it. Okay, so signal quality is greater than 0. And now we want to do a basic send every. So we probably want to put a variable in. I can never spell byte. I don't know why. It's a mental problem. Let's stick a byte in there for message waiting. Oh, sorry. Let's do that. Let's do that. Beautiful. So, why? The reason I'm doing that is because then it breaks between these two tests basically. So, if actually we could just do true, I think. If true, well, it'll be a false, then else do this. So now we've got our test 1 and test 2 broken up, like this. Beautiful. Now I wanted to do time as well. Let's get rid of that for a sec. It's just going to confuse me. Let's move you to where water probably won't work. Let's find out. This could go really bad. Well, the reason I say that is if you get this wrong, the amount of serial data this can fire out to the laptop can be enough to break the laptop serial program. And because this isn't an e-machine, it kind of really clogs it up, and then you struggle to close things. That's why I was like, I better sort that out. Right, before I run it, let's just tidy that up. Now, I wanted to do this on a 2-minute basis, so regardless of what it does, it'll always send a message every 2 minutes, or when it comes to check the next, after the next, X number of minutes, it will do and send and receive and grab that message and then just print it out to serial for fun. So, save it. So we want to use something called millis. Very useful. Is it a long? I think it's a long. A king, okay. Time since last checked. Last sent equals 0. Now, see if I got this right. So there's a function in Arduino called millis. There's also one for micro as well. And this will get you how many milliseconds since it started running the program. I think there is a limit to this. I think is it 49 hours? And then it resets and rolls over back to 0. So do plan for that rollback. But what you can do is, when it started, what we do is time since last send equals millis. So all that's done now is just reset it, and typoed. I can't spell since. There we go. Try and talk and write. Sometimes you just write what you're thinking. It's always bad. Okay. And so if we have signal quality and time since this smaller number and bigger number minus smaller number, it's like that. Otherwise you get negatives. And then we'll set a int message intervals table equals what did I say, 2 minutes in milliseconds. Oh, there's 120 times. Oh, should be able to do this. Come on. There we go. Alright, so that's message interval time in milliseconds. So then is greater than message interval. So then it will go, if the signal quality is greater than that and it has been 2 minutes, then we'll come in here and we'll go serial.println because I want to know if this works. Sending. You know what? It might be better to put it in here. Sending. And we're going to need quotes because this is a double quotes. the string, send a message, send and receive. You know, I don't know why I do that sometimes, but there you go. English is not my forte. So send message, send receive. Now, whenever you're doing it for the first time, you want to check that your code's running right. You can't, as of yet, I figured out, do live debugging because it's compiled and and thrown over to the Arduino. Probably can, or just never looked it up. So what I do is I do a lot of printing. Now, it can be a good thing, can be a bad thing. So let's see if I've made any faux pas. What is quite common to me to do. 03 was not declared in scope. Ah, yes, my bad. I think I need the library for that. I don't think I do actually. Oh, okay. So another important thing, the board that this is currently selected on does not have 3 serials. So then I've got to go, there it is, TNZ4. Make sure you got the board library. You've got the board you want installed. Excuse me, water time. Else it will throw an error because it'd be like, you don't have 3 serials. Now, it always freaks out for a few moments, or I assume is converting over. So let's try that again. Now, I've probably done typos because I'm very good at that. Error was not declared in scope. Oops. There it is. Signal quality. Ah. So it's just setting a variable. Interesting. You know what? I'm going to put them globally, because I'm probably not using them just in the setup, and then that should be fine. So signal, okay, so I assume something sets signal quality then. Oh, go away. Thank you. I just hit on a shortcut. Yeah, okay, well, I might set that one. Okay, oh, compiled. That's a first. So what this will do at the moment is it'll start up, set up the modem, say whether it worked, setting up the modem, and then check the signal quality and print a message out saying sending message every 2 minutes. So might as well give that a go. Let's switch. No, you know what? Stay on the laptop. I'm going to plug in the USB cable into the Arduino. And also, oh, an FYI, on this Arduino, you can disconnect the USB power. What I've done in this case, because I want it to be running off the power that's provided by everything on here, basically. Otherwise, you'll have both power supplies fighting each other, what is exciting. Alright, so I'm going to plug in both systems, and hopefully not see any smoke, because that always happens for me. Okay. Stand by. I'm not seeing any power lights where I expect them. Ah, I see power lights. Oh, loose cable. Loose cables are problems. Okay. I do not see the Arduino turning on. That's nice. It's probably loose wires. Gotta love those. Oh, hello. Ground? Where did it come off? Don't worry about me. Right, so the let's write this program onto that. So it should just go, so there's a little widget that pops up here, programmed. Okay, so we now jump to look at the serial and wait a moment for that. There you go, serial runner. We might, oh, make sure you select the new port. There's a TNZ one. Oh boy, it's warm. Serial monitor. We might have to restart it. Okay, let's restart it. So I'm going to hit the button on the TNZ. It's probably going to trigger. Let's clear that. Good work. This if you push the program again, it'll actually restart it anyway. Okay, reprogrammed. Starting modem. Where are we? We're here. That's not good. Is there a timeout here? Set the right serial. Yeah, check my wiring while that does that. I was expecting it a little bit faster. RX red. God, I should not have multicolored these wires. That seems fine. Now what we can do is we can plug in to the device itself and just check it's up. Because I have a habit of messing up stuff. Okay. Alright, let me grab the USB serial and figure out where I put it first. Oh, here it is. Alright, so I'm gonna swap the teensy over. So I'm gonna plug in another device to the USB because I only have one port on this laptop. Don't ask. And then I'm gonna grab the new wire I made, wherever that went. Lost it already. Yep. Impressive. Oh, here it is. So I need to ground it first. Let's put the ground in. Before ground's in, and then I'm gonna take and unplug the Teensy's USB serial, and I'm gonna plug it into this serial here. So the idea here is that I can then interface directly. I've disconnected the modem. I've interfaced directly via USB serial to it. Now, I'll explain why in a sec. When you're trying to diagnose connection problems, it is sometimes good to have some means of just checking one or the other. So if we pass AT, I would expect it to come back with OK. I'll come into those AT commands in a sec. I think its baud rate's 19200. So modem's available. So why am I passing AT? That's a good question. So modems and most technology that follow an AT command structure, AT is like a standardized terminology of communicating between devices, and you'll get a very large AT command reference documentation. This is 140 pages to use this modem, but what it will detail is every single call that you can make over serial to it basically, and how to do it. So it's like very good documentation. If you want to do more advanced things, you can basically go in there, look it up, and see actually how precise, to a precise degree how it works. So if we go to send, probably find something in referencing send in here. Send SMS. So let's jump to page 48. Okay. Oh wow, I went a bit far. So, for instance, it will give you, so you'll need to put AT on the start of this. Ignore what I'm looking up because it's not actually the right thing. Cool, hold. Yeah, very fun to follow, right? It takes a bit of reading, but whatever command you've got here, you've got to append AT, and then, for example, signal quality. Ring, no. 62. Normally you can jump to the reference, but there you go. You can just do that. So this is saying I need to pass AT plus CSQ. So we can actually try that. They're a bit more complicated than that. This is a nice basic one. And it might respond. 0. And then it gives you a response of X, Y, Z. Yeah. Okay, so that seems to work. If you excuse me for a moment. Hello. Right. Sorry about that. So yeah, it'll give you every reference or command that you can send to this modem, and they're always in the standardized format. It's very useful. A little bit hard to follow. Alright, so what we know is modem's good, so there must be a problem with the teensy or my code. So let's replug it back in and work out how that should go. And double check my connections again, as I can't plug things in. Yellow is RX. RX should go to TX. Yes. Could be even the breadboard's broken as well, because that won't be the first time I've melted it. Okay, so let's unplug the USB to serials. We're not using it now. We could also intercept the signals as well, but hopefully we won't need to do that. Alright, that's that plugged back in. Of course, always got to wait. Okay, back to serial of teensy. Serial manager. Oh, that's not what. Oh, that is what I wanted. Let's restart it again. Start a modem. What have I done wrong here? That's correct, yeah. Why does that stupid? That's always a possibility. Some on hold music. There's always a risk that I wire it back to front. I've done that before. I'm going to try that theory out. Like me and labelling. Never good. Let's try swapping the wires. Oh, yeah. Stupid me. Right, okay. So setup complete. Then it's going to wait for the signal. What we might also do, just so we can see... Let's stick a delay in there, and I want to know what this number is, and I'm putting a delay in there so it doesn't cycle in and spit out as fast as the Arduino can to serial my message. Signal strength, and now copy this in. I'm going to take the first. So what that means is it'll all come on one line, because only the last one of these will then print a new line in. Print that. It's probably going to be 0, and we're going to need to move this to the window, because this thing needs clear sky access. But we'll find out in a minute. Oh, that's unexpected. So 0. Okay. Intermittent signal. Let me see if I can move this somewhere a bit better. So, a 1. So remember, it has to be 2 minutes. That's a good point. You know what, let's wipe out this as well. And it means it should fire into that other one immediately. When it's got some signal strength. What seems like we're in a building as well. Well, it's quite surprising. In a good way, I have to say. I'm just going to put this a bit higher up, so... Okay. Oh, okay. What we probably then do to make it firing quicker. 5,000? Might work. So it then should trigger immediately. How have we got signal in a building? I read on the documentation you need to be in like open sky environment, but either that my signal quality is not working. I should hopefully get it printing out, but I have a feeling Oh, 0, okay. Seems it takes a little bit of time to compute signal qualities. Okay. Why doesn't that work? Why don't we also spit out? No spitting, but no, in this kind of print, and then let's spit out the current, you know, what it's got, how long I think it thinks since it last sent in. It should give us a quite a large number. Don't want to be patient, huh? Yeah, that's a big number. Big number. So message interval. I'm an idiot. Okay. Minus 125,000. Yeah, my bad. Okay. Now it should trigger straight away. I put 5 seconds, but it was 120. That's interesting. Come on, you can do it. I believe in you. Well, also wrong conditions. Put just an exclamation mark. Okay, so we've got the far as that. So we know now. We know now that that part works. We can connect to the modem. So why don't we try basic send? So I'm going to grab some more bits from you. Now, obviously we're going to be sending over this like that long, loads of fun bits of information, up to 50 bytes in length. What isn't a lot really. So we'll send. Well, I've sent a message. Beautiful. And good. Now, how do we check for any messages in buffer? Let me just go through these. There's a function that you can call, but I don't know what updates that function. I think it's a send and receive, I suspect. So we'll also check this value here. I might have actually messages in the buffer already, but we'll find out. Alright, let's stick in print. There we go. Hope this doesn't take long. Waiting. Alright, so that'll give us, you know, we'll comment out. We'll just test one thing at once. Progressive testing. And we'll see if there's what this comes back with. -1. Okay, that's an interesting number. Does that mean there's nothing in there? All right, let's try sending a message in. So what this does then, we'll send to Iridium. Iridium forward it onto Rockblock servers, and then you can actually define what way you want to do it. You can either leave it in the portal, or you can send it onto another endpoint, what we will be doing at some later date. So I'm going to jump into the admin panel, and this is the one they provide. It lets you just manage everything. So now we're going to program it to actually try and send something. Hello world, basically, and we'll see how that goes. And it did not work because I missed semicolon. Probably want to check if that sent successfully as well. So let's just jump back to this. Otherwise you just go, oh, must have worked. I think I also should be clearing a buffer out if it's successfully sent, otherwise it will keep retrying to send it. So let me just find that. Was it clear buffer? Yeah, I should have really taken this example. There's the fail, there's the work. Clearing ammo buffer, clearing buffer. Yeah, okay, let's just use that. That's much better than mine anyway. And then you can obviously tailor it out, format. Standby. Auto format, beautiful. Hello world, you know. There we go. So it will capture it, else it will clear the buffer and then it won't resend it. And we get rid of that. Yeah, commenting is really key, or you lose your mind. I like to do this when it's a single line as well. modes. That's it. Alright, so this then, another important thing is you reset. I'm going to lose my mind here. If it's sent successfully, I don't know, if it didn't send successfully, I wouldn't want it to keep sending. I'll probably just get it to write off the buffer anyway, just because it's old information at that point. I'm not that interested in it. Alright, so this will then do send a message, hello world. And then regardless, it will still reset the time. So it won't, as you can see now, it's trying every single second to go fire it, go. So this will or will not work. Let's see if we can send a message. Okay, so this is the bit I did before. We should get like message sent or not. Now it could take a little while because it's very low signal strength and it's going through a building. Have a little patience. So it's hanging on this basically here, because it's not having a great time at sending it. It's still trying to send it, and I guess it is trying to go up a very long way away. So I might have to move this closer to a window. I wonder if there's a timeout. Oh, there's a timeout. Okay, good. Message sent, clearing buffer. Okay. So it then shouldn't do, it should just go back to sending signal. Oh, because it's sent, you see the message waiting has now changed? So it actually has done a receive at the same time to some degree. So let's see if we got that message. Ah, hello. Hello world. So 12 bytes in length because, you know, hello world. 1 credit used. If we go view, probably going to get a little bit creepy now. Because it can work out timings, it can do an estimated location. And in this particular case, it's not very accurate. It's to 6 kilometers, but very interesting to know. Oh, and then it sent an email to me. Okay, that's my email address. Good. Never mind. Yeah. Oh, there we go. So it gives you a rough estimate of where I am. Obviously, we can't use this because it only goes down to 1 kilometer, but it's quite cool that it can do that. Good. All right, so now we'll try loading a message in. We'll try hello back. We haven't got anything to receive it, but we should see is that message waiting probably won't change. So that's why we need to, well, it will when it then sends another hello world. All right, message sent. So when it comes, I should have put a time till next send. And we're just going to wait patiently and see if that message waiting goes up. And if it does, then we're going to do some coding to do the receive. If it doesn't, it needs the other one, the send and receive, to pick up a message, but hopefully not. Yeah. I'm trying to work out how much it's costing me. I want to see if it just uses 1 credit, but I assume it would say, but you can see that 1 credit used going back. Oh, sending message. Again, it's going to take a while. We can keep refreshing this actually. So. Because I'm impatient, of course. Now, this would be faster if it was outside, but it's going through solar panels, wood roof, felt, inch of insulation. I'm surprised it worked in here, if I'm honest. As you can see, the signal strength varies quite a lot. Not got it yet. It's obviously spending a little bit of time sending those bytes. Do. Okay, message sent. Okay, so again 12 bytes. Now, I don't see it's picked up the message waiting. Now, it could be signal strength problem, or it could be this command doesn't pull it back. So, excuse me, I'm going to go and move to outside. I won't have audio for that. We'll be back in a minute. I will keep the laptop recording, so you'll be fine on that front. One moment. Well, so as I suspected, I don't think it will show any new messages. Without doing the send and receive. Yeah, we'll have to see about putting a check. Sorry, I'm just trying to reposition some motor. Putting a check in there. So after X, it will then try a send and receive instead of just a send. But let's try that out now, actually. Alright, so here's send and receive binary, that one we want. Now what we could do is actually make another function. that's like send message, and then you just change it one or the other. But we'll do it the basic way for now, just to speed things up. So, want that version. Probably want to copy most the same actually. That one. I wouldn't be one for duplicating code like this, but it's the first version. What I did notice is your buffer. Oh, I see. Okay. What's in the? I assume it has a 200 byte buffer, and then it's preloaded into it what appears to be the char values of Hello World. 1, 2, yeah, it looks that way. So we need a buffer now. So we'll bring a buffer in, put it up here, and this will be used for. That's how this library's done it. This will be used for excuse that. The buffer for when we receive. So it will do a send and a receive. So this is probably why that ring indicator comes in handy, because you can understand if you have a message from that and then change to send and receive. What I'll probably do. Okay, and then it's got. This is assuming inbound buffer sizes. Okay. Work out how this is working. Very interestingly, let's put it that way. Okay. Well, are we assuming that it has something ready to receive? Apparently so. I guess if there's a 0 buffer, then alright. So we've got the send, message sent, and then this is the receive part that's confusing me the most. I have a feeling it might be overwriting these, and then this is what's used down here. But I would have probably done a conditional check to make sure that there's something in the buffer. But hey, we can find out, can't we? Now I'm hoping it then updates the message count when it does the send and receive. Let's just validate this is good. Nope. Didn't instigate buffer. Initiates our undefine. Okay. Buffer size, where are you? Okay. Why is it in here? So every time it comes around, it then resets it up. So I might need to specify this above this. I don't know. Could read their library and find it out. Alright, let's see what that does. Oh, we're probably still sending messages out. Let's have a look. Nope, we managed to avoid another one. How did that go? Send it. Did I unplug something by accident? Oh, it's because it's. Let's reset the teensy. Did I break something? There's always a possibility. I don't think the computer's picking it up. No. Okay. What have I done wrong? Not the cable out? All the laptops playing up. That won't be a first. Ah, okay, it's back. Let's program it. Oh. I don't think it'll ever actually come in here. So we want to go, oh, and then go every 2 minutes it sends, and then on the 3rd minute it resets it. Might need another timer. Oh. I can't type. Nope. Right. So we're going to set another condition now. Like it has every 2 minutes it sends, and every 2 minutes it'll send. Then on the 3rd minute it'll do it. 4th minute you could do a send and receive, but I'm going to reduce these down in a sec. I'm also going to create another one. Message interval, message, send, receive, rec interval. And so, to be honest, yeah, I don't know if that's a good idea. This message was this is waiting. I don't think it's going to be so usable now. So we'll do this, and is less than. I'm going to change this to 60 seconds because patience is not my forte. So technically you want it 100, you want it double. So every 1 off, 1 on kind of thing. Let's do that. Okay. And scroll back down. And yes, I did that wrong. There we go. So if it's less than the last interval, else it will come into here. Then we reset that back to now. Want to try it? Let's try it out. So because these are minus, it should then trigger a receive immediately. Let's find out. Should say send and receive. So it should come into the second one, this one here. Now hopefully it will say a slightly different hello world, because obviously I prefixed them slightly differently. This could take a while. Oh wow, we sent them along. Well, credits are going down as I would expect for send basic. Now it might see as these go down in 2s now. We'll find out. Oh, no payload. Oops. Yeah, so that's what I mean. The receives. No, did I lose a message somewhere? Oh no, I think that was the. Yeah, so that's the receive, and there's the send, and then there's the second send. Oh no, I could be wrong. Oh man, this is so confusing. What we're gonna do then is change my message. Oh, I didn't see that. Oh. Did I do that? Whoops. I did. Whoops. Now, then we'll know it's us on the first one. Let's try again. 11:05. See what this does. No payload. Huh. No message right now. Let's send another one. Test 2. Try again. Else we'll have to figure that one out and come back to it next time. Because it's getting very hot in here. I like it. Alright, so that's a send. And we'll probably get no payload again because there's something broken there. Or it's just the way it shows up. Ah. Test 2. Huh. It worked. So I just got to fix the payload thing. Huh, I didn't get charged for it though. Oh, did I? Alright, so we got 85 credits. I kind of want it not to send the first one now, just so I can see how many credits you're using. So if we do that, send another. Let's just stop the Arduino for a sec. Test 3. So we're down to 83 credits. And I set that to 0, so that means that should not trigger until another minute or so. Oh. Did I crash the Arduino? Whoops. Yep. Okay, good. Where are we at? So 83 credits. Refresh page. No, it's not refresh page. Did I break something? Oh no. You know what? I'm a muppet. So the receive is conditional on this one as well. So we need to go to signal quality. It's going to get messy. So we've got one condition, or is greater than. So we've got now 2 entry points into this with lots of brackets. So it should be able to go, as long as the signal quality or one of these two meets the criteria. I really hope I haven't got mistaken that, because it's going to take me ages to figure that out. Then it should enter here, and then because of that, it will go into the else, and we should see a send and receive message. Just refresh you again. Alright, so this should do a receive. Now I have a feeling it's going to use 2 credits, and we'll figure out why it doesn't know payload next time. And that is not the outcome I was expecting. Okay. Oh, there it goes. Now if it uses 1 credit, great, but we'll find out. Then I need to throw a payload in, because then I think it might use 2, but it's all in testing, eh? Oh, hour and 15 minutes. Oops. Bit long this time. So once I've got the sensors running, test 3. Once I've got the sensors running and everything okay, then we're going to test it, and I'm going to work with someone who's called Paul, and I'm going to take a few flights and see how well this works actually in the air for the temperature sensors, for the tracking, and then just see what the data says basically, and see how well it lines up. but that will be in another video. But this time it looks like we got 1 credit used, okay, for receiving. So it doesn't seem like a huge problem, because we can just do a receive manually, or we can unbundle a payload in it, but then it will charge me. So, but it looks like it received the payload, so that's good. Alright, cool, I'm going to wrap this up. Hopefully I didn't bore you to death too much. It took a while, but you actually got to see me pretty much doing it from scratch. So, yeah, that was quite fun. Didn't expect it to work in a shed, but I sent and received data. Obviously, in the main program that runs the weather balloon, it'll probably be functioned up in a nicer way, so I can just call it and go one or the other, and it just be less duplicated, etc. But for now, that's good enough for me. We also got signal strength. Ring, I'm on the bench on whether I use it anyway, but that's it. Thank you very much.